All right, so this one is a pain. I would recommend maybe watching the video for number 35 if you didn't, because that talks about the way that solutions and points of intersection work. We have lines, and there are certain rules for that. This one is changing it up a little bit, and now we're talking about kind of the same thing, a solution, a point of intersection, but we're talking about it with a quadratic. And so our process is going to be a little bit different. So let me just try to make sure we understand what this question is telling us, what this information means. In the xy plane, a line that has the equation y equals c for some constant c intersects a parabola at exactly one point. So the important thing to take away from that sentence is, what do they mean when they say y equals c? That's just a horizontal line. So it's a line that looks like this, right? It doesn't have a slope because it's flat. Its slope is 0. So that makes this actually easier, but there's still a lot of confusing things about this. So they do give us the equation of the parabola, right? And it has the equation y equals negative x squared plus 5x. And so what is the value of c? Now there are two ways to think about it. I'm going to try to show you both. I think this is a good example where I don't know that one is easier than the other. You just need to kind of go with whatever your brain likes best. My brain likes to think about something that's called the discriminant, okay? So the discriminant is a piece of the quadratic formula that helps us understand the number of solutions. So I'm going to first write quadratic formula, and hopefully we have this memorized. You do need to memorize it for the SAT. It comes up rarely, but when it does come up, there's really no way to get it except by memorization. So it's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's the whole formula. What do we use that formula for? We use it to find the roots, or the x-intercepts of a parabola, right? The places where it crosses the x-axis. And sometimes those are easy numbers, in which case we would probably want to factor instead. But sometimes they're really weird numbers, and that's why quadratic formula exists, is it helps us when it's weird to still get those points. But I don't care about those points. What I do care about is kind of like how many of them there are. So what I'm going to do here is I'm going to focus on this piece underneath the radical, okay? That is the discriminant, b squared minus 4ac. What does that help us with? Well, even if we don't look at the other parts of the quadratic formula, this piece, the discriminant, tells us the number of solutions, the number of times it crosses the x-axis. And you kind of need to memorize this. I think it's kind of intuitive, but you might just need to memorize what we're looking for here. If that value is, so I'm going to call it d, is greater than 0, then we're going to have two solutions, two x-intercepts. And the reason is that basically, think about how this quadratic formula works, right? We would get a number as the discriminant. It would be a positive number. And we take the square root of it. It might be a messy decimal, that's okay. But the rest of the quadratic formula, this plus or minus here, means we're going to take whatever that discriminant is, and we're going to add it and subtract it from everything else that's going on in quadratic formula. So if you add a number, you're going to get one value. If you subtract a number, you're going to get another, right? So think about it this way. If we had something like 3 plus or minus 1, right? That's a situation where we actually have two values, right? 3 plus 1 is 4, and 3 minus 1 is 2. So because we have a positive value there, we're adding and subtracting and getting two different numbers. If this is not making a lot of sense, that's okay. Just stick around, it'll get easier, hopefully. So let's erase that so there's no confusion. Because if d is equal to 0, we're only going to have one solution. And the reason is, think about it again. If we had 3 plus or minus 0, in that case, well, 3 plus 0 and 3 minus 0 both equal 3. right? So there's no difference. So if it's 0, we're adding and subtracting nothing. So it doesn't matter that we're adding and subtracting. We get the same result. The weirder one is if d is less than 0, a negative number, then we're going to have no solutions. Now, why would that happen? Because think about where the discriminant is. It's underneath a radical, and you cannot take the square root of a negative number. It's impossible. Try it in your calculator, you'll get an error, or you'll get an imaginary number. So it's not possible, and that's why we would get 0 solutions, because basically, if we did quadratic formula, it would be telling us like, this is not okay, you can't do this, you can't take the square root of a negative number, so there's no real solution. So we're going to use this piece to figure out what's going on with everything else in the question. So first of all, we have a parabola, but we don't really want to use that in this formula quite yet, because we don't want really to find the x-intercepts of that parabola. We need to kind of manipulate our parabola, right? We want to find the point of intersection between this quadratic and this other line that they gave us with c in it. So whenever we need to find points of intersection, what do? Well, we'd like to set the two equations equal to each other if we can, and we certainly can here because they both equal y. So we can set them equal, and we're going to be able to then solve to find the point of intersection. C is equal to negative x squared plus 5x. Now, in order to use the discriminant, in order to find the x-intercepts, which is what it does, I need to have it equal to 0. Okay, so that's a good rule of thumb for most times on the SAT when you have a quadratic equation with an x squared. Your goal is to kind of bring everything together so that one side is equal to 0. And when we do that, we've kind of formed a new quadratic that we're going to use this discriminant thing on. It's confusing. I get it. This is a hard question. But what I would do is move all the x stuff over to the other side. So I'm going to add x squared and subtract 5x. Add x squared, subtract 5x. And now I have a new quadratic equation. Notice it looks a little similar to the other one, but not quite. And now we can use this with the discriminant to know when we have the right number of solutions. Because now we've put it in a form where solution and x-intercept are the same, and so that's why we can use the discriminant. So how do we know what A, B, and C are? Well, remember, the basic version of a quadratic, the standard form, is ax squared plus bx plus c, and that tells us the different values. So whatever the numbers are in front of the different x's, those are the numbers we're going to use in the quadratic formula, and when we use this discriminant thing as a shortcut. So in this case, we're going to take, let's go back to green, b squared minus 4ac. My b is negative 5, so let's square that. Minus 4, my a is 1, right? There's no number in front of x squared, so that means it's 1. And my c is c, so that can go there. And what is it that I want to happen? Well, I want there to be one solution, exactly one intersection. So that means I need to set my discriminant equal to 0. Now I have an equation I can solve. 25 minus 4c is equal to 0. Add 4c to both sides. 25 is equal to 4c. Divide by 4, and there's your answer. C is equal to, I'm just going to leave it as a fraction because you can bubble that, 25 fourths. Oh, it's a nightmare. So the reason that this is actually fast when I do it is I don't need to go over in my head all the different things about the discriminant because I've memorized basically everything on the top half of this page, and so I can know very quickly what I need to do and how to manipulate it. And so for me, there's not a lot of pausing. I'm just able to kind of dive right in, get myself a quadratic, plug it into the discriminant, and set it equal to 0 in this case and solve. That takes practice. Like, that is a hard thing to do. It's one of the hardest things that the SAT is ever going to ask you to do. So I get it if you need more practice with that. There is another way to do it though. If this is confusing you and you're more of a visual person, you can do it with drawings instead, but I still think you need to know a lot about how quadratics work and parabolas work in order to be able to kind of get this. So I'm going to shimmy over here. Let's try a new way. So let's draw a line, make it clear. New way of doing it. So I've got two equations still, y equals c and y is equal to negative x squared plus 5x. What do I notice about those equations from a graphing standpoint? Like I said, I know y equals c is just a horizontal line. I also know some things about this parabola. So this negative here tells me that this parabola is going to open like this, upside down. That is what's called the A term, and if it's less than 0, it's going to open as a frown. If it's greater than 0, it's going to open as a smile. We've seen that on other questions in this exact same test, so hopefully you've come across those videos and are familiar with this. But what that means then is, in order for me to have a horizontal line intersect this parabola just once, right? It has to do it just once. There's only one place where that can happen, and that's right here at the vertex. So right, think about it. That straight line, it has to just glance this parabola. If it's a little bit higher, it's not going to touch it at all. If it's a little bit lower, it's going to hit it twice, right? Because a parabola is like symmetrical, so it's going to have two spots where it crosses. So there's this one place where this horizontal line is going to touch this parabola one time. Now, we can find the vertex of a parabola in all sorts of ways. The one that I really like is the vertex, the x-coordinate of the vertex is equal to negative b over 2a. Okay? So we have the b and the a because ax squared plus bx plus c is the standard form of a quadratic, like I said before. So we can match up these values and try to get the equation. So in this case, the b is 5 and the a is negative 1. So 2 times negative 1, we got to be careful that we don't lose that negative. So negative 5 divided by negative 2 is, the x-coordinate is 5 halves. But that's not the answer, because I don't care about the x-coordinate of the vertex. I care about the y-coordinate. How do I know that I care about the y? Because look it, they asked me for the value of c, and c is equal to y. So I got to find y. And we can do that just by plugging in this x value into the original equation. So this x can go in for all the x's here. So that's going to be y is equal to negative 5 halves squared plus 5 times 5 halves. And we have a calculator for this, so you could just turn these into decimals and do it that way. I haven't used it yet, so I'm going to kind of keep that trend going and just work with the fractions. So let's simplify. Y is equal to negative 5 halves squared is 25 fourths. Plus 5 times 5 is 25. 2 times 1 is 2. So negative 25 fourths plus 25 halves. Scroll down here. Well, in order to add or subtract fractions, you need common denominators. So that's y is equal to negative 25 fourths plus, let's multiply those by 2, 50 fourths. Negative 25 plus 50 is 25 fourths. The same answer that we got before. Well, is that easier? I don't know. I don't think so. I think it's whatever you see. And there is a third thing that you might see if you look at this, and that is that it's going to be a complete disaster and it's not worth your time. And quite honestly, that might be the best option. This is only 10 points. this 10 points is not somehow better than the 10 points that you might get on number 37 or 38 if you just skip this and go on to those other questions. Technically, 37 and 38 are supposed to be harder because they're later in the section. But if you don't get this, this is going to be really, really hard for you. You might get whatever topic is coming up. So you have to be a good judge of what you're up against and know your weaknesses. If this doesn't make sense to you, even after I explained it all, this is one of your weaknesses. And that's okay, because it's a minor weakness. This doesn't come up very often. So you're only really concerned about a question like this if you're already getting very close to like an 800, you know, and this is like that last little point that you need to get. Then yeah, you better learn this and get it down, because it could be the difference between a 750 and an 800. But if you're not near a 750, this is not worth your time or your effort. Don't study this. What are you even doing watching this video still? I've been rambling on for 15 minutes. So prioritize things. Hopefully this is not going to be on your SAT, but if it is, totally fine to skip it and you know, go on Khan Academy. You can learn much more about this. This was like the crash course, but yeah, it's not easy. It's hard. That's okay. That comes up on the SAT sometimes.